Okay. Now we will see the another problem. In this problem, the problem says that the radius of the earth is 6.37 into 10 raised to plus 8 centimeter. Means again radius of the earth. See, radius of the earth equals to 6.37 into 10 raised to plus 8 centimeter. Its a mean density, again he says it's a mean density 5.5 gram per cubic centimeter. Means that we have to write rho 5.5 into gram per cc, and the gravitational constant is g, and this g is nothing but 6.66 into 10 raised to minus 8 in CGS unit. CGS units. Yes, CGS units we know dynes centimeter square per gram square. Now, once again I will repeat the problem. The radius of the earth is 6.37 into 10 raised to 8 centimeter. Its mean density is 5.5 gram per centimeter per cc. 5.5 gram per cc. We have to write cc, cubic centimeter, and the gravitational constant is g, 6.6 into 10 raised to minus 8 CGS units. Therefore, here we are interested to find out, to calculate the Earth's surface potential. Earth's surface potential. Here, keep in mind, Earth, we are going to consider as a perfect sphere, and for that we are having the formula for calculating the Earth's potential, surface potential. V equals to, here V equal to Gm by R, but here we know G, we having a value of R, because in this case R is nothing but R also. But what about the M? Then for calculating the potential we should know M. What is M? M is nothing but the mass of the earth. How it can be calculated? Now M equals to, that is a volume multiplied by density, because we are considering Earth as a perfect sphere. When it is a perfect sphere, we should know its a volume, and volume is given by 4 by 3 pi r cube into rho. Into rho is a density. Friends, now part is only of calculation. 4 by 3 we know value of the pi, then r cube, and then multiply it by rho, and then afterwards we have to put these values in the equation V equal to Gm by R in this formula, and therefore here we get it. See, we will put here for our sake of convenience 6 G. Yes, here m equals to volume into density, and therefore m equals to 6. Yes, this is the formula, but in this formula m equals to what? M equals to here, m equals to what will be the modification? V R upon G upon G. The value of G is 6.37, 6.66, and by putting the values here we will get m equals to 6.66. What is 6.66? The value of G. How it has been done, we will see here once again. The problem is 6.66. V equals to, we have to calculate the V, and V equal to Gm by X. V equal to Gm by X. Yes, and if here we are interested to find out, calculate the Earth's surface potential. Yes. If it is not here, it is not necessary. We have to calculate Earth's surface potential. Now, Earth's surface potential, that is nothing but V equals to G having a value of 6.66 into 10 raised to minus 8, then m, this much quantity we will write here, multiplied by 4 by 3 pi r, value of r, this value of r 6.37 into 10 raised to 8. We have to make a cube of r cube into rho. What is a rho? Into rho means multiplied by 5.5. This is sufficient. Then divided by this whole quantity, divided by r, that is 6.37 into 10 raised to 8. Yes, you can see. See now once again, in this formula, G, value of G is 6.66 into 10 raised to minus 8. M, we will put the factor m here. Then R divided in the denominator of this whole quantity in this way. And see friends, here by calculating all these terms, we will get potential, surface potential V equals to 6.222 into 10 raised to 11 ergs per gm. Ergs per gm. This was the problem. Now one more problem we will see. It is also one of the simple problem, and you can solve it. You have to solve it. If you are able to write, you can write. If again here he is giving the value of gravitational constant G equals to 6.66 into 10 raised to minus 11 Newton meter square per kg square. Now here the values or value of gravitational constant is given in the form of SI unit. And what is the force between two small spheres weighing 2 kg? Means M1 is also 2 kg, M2 also 2 kg. These are the two small pairs, and these two small pairs are placed at a distance 30 centimeter apart. 30 centimeter apart means distance between that is 30 centimeter and 30 centimeter apart. Now see here, uh, all these are in SI, means MKS. Now we have to convert this unit in meter, and therefore we will take it in the form of 30 centimeter means 300 multiplied by 10 raised to minus 3 meter. See friends, we know the formula F equals to M1 M2 upon R square into G. This is the formula. We are having a two masses. We will take it M1 into M2, 2 multiplied by 2 divided by R square means square of this 300 multiplied by 10 raised to minus 3, make a square of it, multiplied by G, that is 6.66 into 10 raised to minus 11, and by making all the calculations we will get the force. What he says, force between the two small spheres we have to find out, and it is nothing but F equal to 2.95704 into 10 raised to minus 7 Newton. This is the required answer for this problem. Friends, now you can have, or you have to solve the another problems also. In this chapter, the important things or important questions you may write that in annual examination they may ask state the law of universal gravitation and describe a method of determining the gravitational constant. Then again you may have the question that explain the terms gravitational potential, gravitational field, and obtain expression for gravitational potential and the field at the point inside, outside a hollow spherical cell. This question was also asked from Mumbai University. Then one more question you can have, define and explain gravitational potential, calculate the gravitational potential due to a sphere at any point outside the sphere and inside the sphere. In this way we have completed the first unit, mechanics, and this mechanics, this unit you may give 10 to 15 marks in semester examination. Therefore, you have to be aware about the study, about the problems, means to solve the equations and problems, also important in the chapter mechanics. Thank you. Thank you.